So in this video I'm going to talk a little bit about the difference between measurements of a sample or of a whole population. So let's imagine this. Let's imagine that we want to work out the average height of a human being, and the true way to do that would be to take a population mean and that is represented by the symbol mu. So this is the same symbol as when we're talking about microliters or whatever, but in this case it means population mean, and that's equal to the sum of x over n. So that's for every single individual in the whole population. So in this case it would be, we'd have to measure the heights of all the people in the whole world. But obviously that's not very feasible, and it's an extreme example obviously, but my point stands. So the population mean, so we have to choose a sample out of that population, and that's what we talked about yesterday. So that's x with the bar over it, and it's the same equation, but it's got a different name. But of course we have to take a random sample from the population. So this is an important concept, random sampling. And so let's imagine here's my population of blue dots, and I want to measure something from them, but I only want to measure 5. So let's imagine I take this one, this one, this one, this one, this one, or I could take this one, this one, this one, this one, and this one, or I could take this one, this one, this one, this one, this one. Okay, and if each of these individuals has a different phenotype, if you like, then we're going to get a slightly different sampling, and therefore a slightly different population mean from each of these samples. And that's what I'm going to talk about next. So that's the whole principle of the standard error of the mean, which is going to be the topic in a minute. But for now, I want to talk about, so we've got the sample mean, which may or may not be the same as the population mean. And also we've got the standard deviation. So we've got the sample standard deviation, which I was telling you lies last week is actually called S. And that is equal to the sum of x minus x squared all over n minus 1, as opposed to the true population standard deviation, which is sigma, and that's the sum of x minus so this should be mu, shouldn't it? The mean of the whole population all over n minus 1. Sorry, all over n. I'm talking rubbish. Okay, all over n. So the difference here is that we're talking about the sample mean as opposed to the population mean, and also this is n minus 1, and in the population standard deviation that is n. And I don't want you to worry about that too much, but this is just a way for making sure that the standard deviation gives an unbiased measure of the dispersal in the sample. Don't worry about that too much. The point is, in a sample standard deviation, you're dividing by a minus 1. Population standard deviation, you're dividing by n. And so the sample mean and sample standard deviation can be thought of as estimators of the population mean and standard deviation. So my point here is that random sampling from a population allows you to calculate the sample mean and standard deviation, which is a good estimator probably of the population mean and standard deviation if you're doing random sampling, but you have to calculate the standard deviation in a slightly different way.